I welcome you all for this presentation. In this presentation, we are going to discuss about Introduction to Stacks. We are just stepping into Unit 2. This is the overview of this presentation, Introduction to Stack Data Structure, then Stack Abstract Data Type Operations, then some of the applications of stacks. Then I have given you some practice problems followed by summary of this presentation. So what is a stack and what is the need for stack data structure? So all the data structure are used for storing the data or organizing the data only. Here the stack is also one of the data structures, and the stack is an ordered list in which insertions and deletions are made at one end called top. So here we have to learn some new terms. One term is top. So insertions and deletions are made at one position or one end, that we are calling it as top. In some books it is also given as peak. So top or peak means you have to know it is top only. Peak means also top means also peak. So you have to know it. And this stack we are calling it as last in first out list. Why we are calling it as last in first out list means whichever enter first has to come out last. So whichever enter last have to come out first. Here you can see the bangle. So which bangle entered first, it has to come out last, and which bangle entered last, it has to come out first. So this way, this is one real-time example for this stack data structure. Likewise, many examples are there. A pile of books, then pile of coins, then the folded dresses. So arrangement of books, many things, many examples are there. So we can see many real-world examples for this stack data structure. So here we already discussed that insertions or deletions are made at one end called top. And the name of the insertion operation is push. Insertion means pushing it into. Deletion means pop, taking out. We are popping out the data. That is deletion. So here we have seen three new terms in addition to this stack. One is stop. That is the end where insertions and deletions happen. Then the insertion operation is called the push. Deletion operation we are calling it as pop. So here I have given you an example. So this is the stack. So first A is pushed into the stack. So the top pointer is pointing to this A. Next B is pushed into the stack. So top pointer is moved to B position. Then C is pushed into the stack. So top is pointing C. Then D is pushed into the stack. So top is D. E is pushed into the stack. So top is pointed to E. Now if I want to remove E, that is I want to perform pop operation. So I am just popping off. That means the top element is popped out. So E is popped out. So automatically the top moves to the next position. So D. So this way only we are performing push and pop operation. So if you want to push means it is placed here. If you want to pop means you have to remove it off. And afterwards if I want to remove red color, it is not possible. After removing yellow only it is possible to remove the red. So it is last in first out. Last in first out. Okay. LIFO list. So these are some of the examples of stack. A stack of cafeteria trays, then stack of pennies, stack of shoe boxes, then stack of neatly folded shirts. These are some examples. Then bangles in a hand, then books in a rack. Many more examples we can tell. Next is stack abstract data type operations. In the first or second presentation itself, we have seen what is the abstract data type. That is, it is mainly the abstraction of a data structure. That is, this abstract data type specifies what data we are storing, then what are the operations we are performing on the data. In addition to this, the data storage as well as the operation, it just tells the error conditions associated with the operations also. So here error conditions in the sense in a stack data structure we are having two things. One is called as overflow and another is called as underflow. Overflow in the sense if the stack is full and if you are trying to push something in the stack at that time an error condition occur, that is called as overflow. And if the stack is fully empty, no elements are there in the stack, and if you are trying to pop any element from the stack, At that time, we face one error condition that is called as underflow. So these are the error conditions associated with this. Abstract data type means the implementation is hidden from the user. It is not shown to the user. All the data stored and operations are only known. The implementation details are totally hidden from the user. So the abstraction of the data structure. Here, what are the operations we can perform using this stack means create, it is to create an empty stack, then destroy, it is to destroy a stack, then empty, empty is to empty the stack, that is it returns true if the stack is empty, otherwise return false. So we are just checking empty the stack in the sense we are checking whether the stack is full or empty. Suppose in the empty stack if you are performing pop operation, some error conditions will be coming. So we are checking whether the stack is empty or not. If it is not empty, then only we are popping the data. Next is push. Push is inserting an element in the stack, that is adding new item to the top of the stack. Then item pop, that is removing the top element from the stack. Then top means we are just returning the top element of the stack. Without removing it, this is the top element, we are just telling or printing, that's it. So these are the different operations performed using stack data structure. Here I have given you one example to perform push and pop. In the free time, if time permits, you please try to do it. I am doing only a few operations. First it is push 8, so I am pushing 8. Next is push 3, so I am pushing 3. Then I am performing pop operation. So what happens? I am popping the top element. So I am having only 8 here. Then I am pushing 2. So I am having 8, 2. Likewise it goes on. So finally if I pop, performing pop and there is no element in the stack and again I am performing pop means that underflow condition occurs. So you please try this one. Next, applications of stack. Here we are going to discuss only 3 applications, but many more applications of there. One is the parenthesis matching. Here each of open parenthesis, then curly braces and the square bracket must be paired with the matching open parenthesis, close parenthesis, then right curly braces and this one, it is closed, it is not open, it is closed bracket. So always we have to use all these things. These must be in on order only. So this way only we have to perform all the parenthesis matching. Otherwise it will display some error. So the correct form here you see open parenthesis, that is left parenthesis and right parenthesis. So it is matching here left then right. So matching, then left curly brace, left parenthesis, left square bracket, left parenthesis. Again it is matching with this one, then it is matching with this is matching with this and this is matching with this. So here the parenthesis is matched. If you look into this, here you see 3 opens are there, here one close. So this is matching with this. Then here this is matching with this and this is matching with this. Here we are having curly brace, left curly brace, left parenthesis, left square bracket, left parenthesis. So it is matching with this is matching with this is matching with this. But here there is no close curly brace available. So no close curly brace available. So not matching. And again these two are open. It is not closed. So this is incorrect. Then here you see first itself it is a close. So anyway it is a incorrect only. Then here you see open this one bracket, this parenthesis. Then open left curly brace and left bracket, square bracket, then right square bracket. This is matching. Here you see it is a close parenthesis, that is right parenthesis. Instead of right curly braces, it is a right parenthesis. So it is wrong. Here it is only open, so it is wrong. So here I have given you an example. You please work out and check whether it is matching or not. The parenthesis is matching or not. You please check it. Next application is infix to postfix conversion. These are the steps to follow to perform infix to postfix conversion. That is, we have to print the operand as they arrive. And if the stack is empty or it contains a left parenthesis on top, we have to push an incoming operator onto the stack. And if the incoming symbol is a open parenthesis, that is left parenthesis, we have to push on to the stack. And if the incoming symbol is a right parenthesis or closed parenthesis, we have to pop the stack and print the operators until the left parenthesis is formed. And if the incoming symbol has higher precedence than top of the stack, we have to push it onto the stack. If the incoming symbol has lower precedence than the top of the stack, then pop and print the top of the stack. Then we have to test the incoming operator against the new top of the stack. Here, what do you mean precedence? For each and every operator, there is some precedence associated. One example is this multiplication, division, remainder operator are having same precedence. But plus and minus are also having same precedence. But plus and minus are lower than the multiplication and division operation. So you have to check which operator is having which precedence, you have to know. So based on that only it is possible to perform all these operations. So if the incoming operator has the same precedence, suppose we are having plus and minus, in that circumstance what we are going to do? So there we have to follow the associativity. That is, this operator works from left to right or right to left. Based on that we have to follow the associativity rules here. So if the associativity is from left to right, then pop and print the top of the stack, then push the incoming operator. If the associativity is from right to left, then push the incoming operator, and at the end of the expression pop and print all the operators on the stack. So this way we have to perform infix to postfix conversion. Before that you have to know what is infix, postfix and prefix. Infix means the name came based on the position of the operator. So A and B are operands, and if operator is between this operand, then it is a infix notation. If the operator is next to the operand, then it is a postfix notation. If the operator is placed before the operand, then it is a prefix notation. So this is infix, postfix and prefix. The stack can be used to convert infix to postfix. Because evaluation of postfix expression is simple using stack, so we have to convert infix to postfix before performing the postfix evaluation. This is one example for infix to postfix conversion. Here I have given you a simple example only. Always we have to scan from left to right. So first is the symbol. It is placed in the stack. There is no output. Next A, it is operand. Then we have to place it in the output, that is printed. Then slash, it is operand. So just we are pushing into the stack. Then open parenthesis, pushing into the stack. Then B, it is operand. So you have to print it. Minus, it is operator. So you have to push it into the stack. C, operand. So print it. Then close. Once we encounter a close, what we have to do? We have to pop it off up to the first left parenthesis. So here minus, we are printing it and we are popping out. Next is star. So if slash and star, slash is there, star is also there. So both are having same precedence. So what we are doing is, we are just popping off slash and we are having this star alone here. Then D, it is operand, so we are printing plus. Plus, if you look into star and plus, plus is having low precedence compared to star. So always at the top of the stack, the higher precedence operator must be there. We can't place a lower precedence operator at the top of the stack, that is above the higher precedence operator. So we are just removing this one star and we are placing plus. Then E, it is operand, so we are printing it. Then close, so we are popping out and printing this plus. So this is the way to perform infix to postfix conversion. If time permits, you try to work out and find based on the algorithm whether it is working or not. Next is the postfix evaluator. Here we are scanning the expression from left to right, and if there are any operand is encountered in the expression, then we are pushing the operand in the stack, and when any operator is encountered in the expression, then pop the corresponding operands from the stack. So when scanning of the expression is finished, then the final value remains in the stack. Let us see one example. So here you see, this is the postfix postfix expression. This only we are going to evaluate. See here, always we have to scan from left to right. So first is 4, next is 5, Next plus, so you have to perform addition. That operation you have to apply and you have to perform some operation here. Then 9 is there, 7 2 likewise. See here, first 4 it is pushed into the stack, then 5 it is pushed into the stack, then plus. So what happens? We are just popping these two elements and performing this operation and storing the result in this stack 9. Then 7, so 9 and 7. Then 2, we are just pushing into the stack. Then minus, so we are popping two operands and we are performing the operation, that is 5. Then star, so we are popping two elements and we are performing that operation and storing the result in the stack. So I have given you some problems to practice. Three from the postfix, evaluation of postfix expression, and 3 to convert infix to postfix. Try to solve all these problems. So in this presentation, we discuss about the introduction to stack data structures. Then we discuss about the stack abstract data type operations. Then we discuss some of the applications of stacks. And I have given you 6 problems to practice based on the applications of stacks. Thank you.